In this video, you and I, for the first time ever, will be going through an entire Pure Mathematics Unit 1, Paper 1 past paper, which as you know is all multiple choice questions. And for every single one of these MCQs, we will be going through in great detail, or at least the level of detail that I thought was appropriate, for you to be able to apply these concepts to questions in the future, and hopefully be able to apply them in your exam. So let's begin now. Let's begin our journey with question 1, which comes all the way from module 1, and it is likely one of the first topics you'll ever encounter or learn in pure mathematics. This question is all about surds, so let's read it now. Question 1 states, the square root of x minus the square root of y all over the square root of x plus the square root of y may be expressed as, and then we are given these 4 options. So the first thing that I'd like you to actually do besides reading the question is to scan the options. Always scan to see if there's anything peculiar, if there are any similarities or if there are any differences between the options, because this could give us great clues as to what the answer may be. Okay, so the first thing that you'd notice is that the denominators in all of the options no longer have square roots in them. Okay, and this is a huge clue for us, and this should ring a huge bell in your mind as well, okay? Because when we see that there are no longer the square roots in the denominator, we are going through a process called rationalization of surds. But let's begin from the basics, the fundamentals. What even is a surd? Okay, that's a great question. So surds are actually square roots of numbers that cannot be simplified into a whole or rational number. So for example, the square root of 2 and the square root of 3 are both surds because you cannot simplify them into rational numbers. However, the square root of 4 is not a surd because the square root of 4 is equal to 2. The square root of 9 is not a surd because that is equal to 3. Okay? So examples are the square root of 2, the square root of 3, and the square root of 5. Okay? So now, realizing that this is about surds, which is the first thing that you notice, and that they are no longer surds in the denominators. We have only 2 options for the denominators, x minus y and x plus y. The bell that's ringing in your head, rationalization of surds. And this is the process by which we remove a surd from the denominator by multiplying by its conjugate. So that's another great question. What is a conjugate? So that is one of the simplest things, my friend, because all you have to do is flip a sign, okay? So let's actually look at the solution now. All right. So looking at the solution, we first restate what they asked us, okay? So we have the square root of x minus the square root of y over the square root of x plus the square root of y. And remember, removing the surds from the denominator by a process called rationalization. And this is multiplying the numerator and denominator, both of them, by the conjugate of the denominator. So all we had to do to find the conjugate was flip the sign between these 2 terms in the denominator. So it goes from positive to negative. And all we do now is we multiply both the numerator and the denominator by this conjugate, one over the other. And why one over the other? Why do we need to multiply it by both? It is because doing this is permissible because this is equal to 1. All right, so we're not actually changing much. We're just putting it in a different form to express it in a different way, okay? So we're going to expand the numerator and the denominator. And this is probably the hardest part after recognizing what we needed to do, because you have to be aware of the signs. Always remember, positive multiplied by a negative is equal to a negative. And I know you know that by now, but just remember and look at them, because it's so easy to make mistakes. That is one thing you might make a mistake on in this question. I hope you don't, but yes. So we simplify and we get x minus 2 the square root of xy plus y over x minus y. So now we're going to scan the options. We scan in all the options, and all we need to do was switch the plus y over there, and then we get it into a recognizable form to make it one of the options. And we see that the answer is A. So that was question 1. Question 2 is all about the summation notation, as many of you may know it by the sigma notation, which is the Greek letter sigma, or others may know it as capital letter E. Okay, so what it means is the sum of. Okay, so using the summation notation, the series 3 minus 9 plus 27 minus 81 plus ellipses, which means all the way to minus 729, may be represented by one of these four options. Now, one thing we need to note is the method by which I will be solving this question with you all is brute force option testing. In other words, the process of elimination. So we will be substituting the values 1 through 6, or 1, 2, 3, 4, or 1, 2, 3, to be able to see if it reproduces our values, so these terms, of this series accurately, including the signs. And this is because I think, for the sake of time, this is the quickest thing that we can possibly do. So even using your calculator or your mighty brain, you can quickly do these calculations and eliminate options. And in our case, hopefully it's not option D, because then we have exhausted A through C, and then that would have been a waste of time anyway. But yes, I want you to note that there are other options, there are other ways to be able to do this question, so just keep that in mind. All right, so let's begin. We are given the series, okay? So we notice that there is a link between them, because when I multiply 3 by 3, I get 9. When I multiply 9 by 3, I get 27, and so on, okay? But for the sake of the way we're going to solve it, that doesn't matter at all. So let's start by substituting r is equal to 1. We'll start with option A. If we substitute r is equal to 1 into A, and the first value that we get is incorrect, we immediately eliminate that option. So as you can see, we get minus 3. Our first term in our series is 3, okay? The reason we eliminate it is because they are not equal to each other. So eliminate A entirely. We go on to B. And as you can see, B is working out quite nicely for us, because when we substitute r is equal to 1 into this option, we get 3 as the first term. When we substitute r is equal to 2, we get minus 9, which is the second term, 27, and minus 81. So therefore, we can make the conclusion that B, option B, is correct. But if you are as anxious as me and just want to make sure and have any level of anxiety, I could quickly test options C and D as well for the first terms, and you can notice that they are wrong. So that was like the quickest way that you could get through this. If you have any other ways, please feel free to do that. But I think for me, and for most of us, this might be the fastest way to get through question 2. So we can eliminate A, C, and D, and have the final answer to be B for question 2. Question 3 is all about being Google Translate, or some kind of translator, right? But the thing about it is, I want you to think about it like this. It's like a code. You're trying to decode something or code something. It could go both ways, right? So think about you and me. Only you and me know what the code is, because we don't want anybody else to find the goal at the end of the rainbow, right? So only you and I know that if we say R, that means they have a rainbow. You understand? So keep up with me, right? So here it is. P, Q, and R are the propositions such that P, and don't tell anybody this, P means it is raining. Q means the sun is shining. But R, this is the important one, means there is a rainbow. So only you and me know that, right? This is just for like fun. We're thinking about it like that. It is basically just translating this, okay? We have to say this expression. So if I wanted to tell you that it is raining and the sun is shining, but there is no rainbow, and they had somebody else there, and they don't know our code now, they don't know what P, Q, and R means, I'm going to write it to you like this, okay? So let's break it down. It is raining, we know is P, right? So I'll tell you P. Then I will tell you the roof of a house. So this symbol, well, I would write it, I can't tell you, right? So I would write P, the roof of a house, right? You know why this is the roof of a house? Is because you and me in the house together. You understand? That's why it's in and. The sun is shining. I'll say P and Q, but, so this also acts, it functions like and, okay? So the symbol we would use for but is still this. There is no rainbow. So no is the squiggly line. Okay, so I will write to communicate to you that it is raining and the sun is shining, but there is no rainbow. I would write P and Q and not R. Okay, so that is exactly how I would communicate to you in our secret code this message. Okay, so that's our answer. That's the answer to the question. Okay, so to communicate this, I would simply write C. Okay, so all you have to do is code it properly. Remember, this is and, this could also be but, and this is not. Okay, so that is all you had to do there. Question 4 states, and this is also reasoning and logic. You see, we're having so much fun with this topic. The contrapositive of the statement, if Jomo is a minor, then he is rich. And we need to find the contrapositive of the statement. So first thing we need to define is the contrapositive, right? So we know that the contrapositive of P implies Q is going to be not Q implies not P. So we flip in and negating, all right? So let's look at the statement. If Jomo is a minor, then he is rich. So that's P implies Q, right? We want not Q implies not P. So we know that not Q is Jomo is not rich, and not P is Jomo is not a minor. So not Q implies not P, in this case would be if Jomo is not rich, then he is not a minor. And that is the contrapositive. The key in this entire question is remembering what contrapositive is, okay? Because there's not only contrapositive, there is the original, P implies Q. There's the inverse, which is not P implies not Q. There's converse, which is Q implies P. And there's the contrapositive, which is what we needed to remember just now. So what if they asked us, what is the converse of the last statement, right? We would have to know that instead of putting what we just put as the contrapositive, we would have to put Q implies P instead. Okay, so it's about learning that. So to remember the converse, I always remembered that when I was younger, I used to wear Converses. They were my favorite shoe. And I was also kind of backward then, right? So you flip them around. P implies Q. The converse of P implies Q is Q implies P because I was backward then. So that's how you can remember converse. Contrapositive, oh god, that's just flipping and negating. Flip the whole thing and you're negating it, right? So not. And then inverse, all you had to do is add the squigglies. So you're good. So just memorize those and you'll be able to solve these like nothing. Question 5 is all about the real ones. It states, if f maps real numbers onto real numbers, then f of x is equal to 3x minus 1 is best described as which one of these options? So let's recap on what these options actually mean. So we know that one-to-one, or injective is the other name for it, means that each element in the domain is mapped onto an element in the codomain. So it has a unique output in the codomain, okay? Now, onto also means surjective, means that the function hits every possible y value in the codomain. Okay, so remember this is the domain, this is the codomain. I know you all remember those maps. So bijective now means that the function is both injective and surjective. So it's both one-to-one and onto. So if you test positive for one-to-one, don't just stop there. Always test for being onto as well, because it could very well be bijective. The function can very well be bijective. Just a note that inverse functions, only bijective functions have well-defined inverses over the entire domain. That's just a note. And for many-to-one, multiple input values from the domain can map to the same output value in the range. Right? So if you need a quick recap, go and look at those little diagrams where they map in them, just to, to refresh. So let's look at the solution. Our options, again, were bijective, surjective, on one-to-one, and many-to-one. First, thing we are going to do is test to see if it is injective or one-to-one. And the way that we are going to do this is see that when we substitute a and b into the function and we simplify, if a turns out being equal to b, the function is one-to-one. Okay, that's how we test if a function is injective. We are going to substitute a and b, try and simplify it as best as we can, and if a is equal to b, it is one-to-one. All right, so let's test it quickly. We're going to substitute a and b, make them equal to each other. We can cross out this, we could cross out this, we get a is equal to b, and it is in fact one-to-one. Good job, guys. But do we stop there? No, we don't. Why? Because bijective also means that it could be one-to-one, but something else. Say it. Yes, surjective. Okay, surjective or onto. How do we test for that? So, is it onto? To be surjective, every y value must have a x value, right? So they need to be 1 for every y value. They have to be a valid x value that I can map onto, okay? So the way that we do that is we let y is equal to f of x. When we do that, we make x the subject of the formula. And we can see here that there is a valid real x for every real y. So that means that the function is in fact onto. That's why I told y'all, don't just stop at injective, because it could just be surjective too. And now the answer is bijective, okay? So we can draw conclusions because we have enough information. Oh, don't just draw conclusions otherwise, that will get you in bad places, just in life in general. Life advice, right? So the function is bijective because it is both injective and surjective, and we have enough information to see that that is in fact the answer. Now, a quick note, because we could have done this much faster. For linear functions, so for linear functions like f of x is equal to ax plus b, where a is not equal to 0, the function is always bijective, okay? So I could have told you that from the beginning, but I also want you all to know how to prove it. Many to one happens with curves like x squared, so not lines, so we could have also just crossed that out immediately, eliminated that whole option entirely. And the shortcut is just straight lines are equal to being bijective, as long as the codomain and domain are real numbers. Okay, so those are just shortcuts, but again, we went through that whole solution just so you would be able to solve it on your own. Question 6 states that the expression ln of x, y squared, and the cube root of z may be written as one of these options. So 3 of these are the imposter, okay? And we need to figure out which one is the real one. So you know when you put on your fancy clothes and thing, and you look different, but you're actually the same person, we just need to figure out what they're wearing today. What is this guy wearing today? And the way we're going to do that is by using the properties of logs, or the laws of logs, all right? So we know by the product rule that ln AB is equal to ln A plus ln B, and the power rule that ln A to the power of R is equal to R ln A. So the exponent of the number of a log can be moved in front of the logarithm and vice versa, okay? So let's use them. Let's discover who he's disguised at today, or she. So we are given ln x y squared multiplied by the cube root of z. What we're going to do is break it up. So let's make it simple, okay? We're going to use the product rule, break it up. Ln x plus ln y squared plus the ln of the cube root of z. And we know that by the power rule, we can pull this in front as well. So we're actually going to do this lower down, right? But we know that the cube root of z is also equal to z to the power of 1/3, okay? And we're going to use the power rule to bring the third in front, okay? And the same for the square, actually. This is great here because this becomes 2 ln y as well. So we have ln x plus 2 ln y plus a third ln z, all right? And that's all we did using the power rule in this step 2 here. And then you realize he wasn't even dressed that complicated. He only probably put on just like a suit and a tie and some glasses, because that's all we had to do to figure out who he was, you know. we could see that he's clearly, very clearly B, and everybody else is an imposter, right? So this is how you all know I was real good at Among Us. I just see I was real good at Among Us. So that's how you solve question 6. So I want you all to recap on the laws of logs, because there are loads more that you actually need to learn, and they're very, very helpful in solving questions like these. Question 7 states that if log base A of 16 is equal to 5, then log base 2 of A is equal to which one of these options? So this question is all about exponential and logarithmic functions. That being said, we need to understand the basic exponent and log equivalence. So we need to be able to convert between the exponential form and the logarithmic form, because this relationship can help us solve more questions than you know. Okay? It is so basic, and to make it even basicer and simpler, I color-coded it for you. So we have pink for the B's, we have orange, A's, and the X is purple. Okay? So just keep that engraved in your mind, because we're going to use it now. Okay? So we are given log base A of 16 is equal to 5. The first thing we need to do is find A, because when we find A, we could solve the whole thing. Because all we have to do is find log base 2 of A. If we have A, we could compute it. So you see, big brain, guys. Step 1, convert to exponential form using this relationship. We know that log base A, 16 is equal to 5, can be converted into A to the power 5 is equal to 16. Okay, so this is much easier on the eyes. So when we solve for A, we know, first of all, that moving this across, we get 16 to the power of 1 over 5. And when we find A, we are able to now put log base 2 on both sides. So when we do that, all we're going to do now is, since we have what we want on the left-hand side, all left to do is simplify the right-hand side. So if y'all have a fancy calculator, this could be the end here. But for all of us normal folk and basic fellows, we have to simplify more. Okay? Well, honestly, most of you all probably could be done by now, but just to be able to understand how to go forward, what we're going to do is move 1 over 5 to the front. Then we have 1 over 5 log base 2 of 16. You and I both know that 16 is equal to 2 to the power of 4. So when we do that, we can move 4 to the front again, multiply 4 by 1 over 5, and we get 4 over 5. And we also know by the laws of logs that log base A of A is equal to 1. And bam, 4 over 5. That's our answer. So our answer is A, 4 over 5. Good job. Question 8 states, the equation 5x cubed minus 2x squared plus 4x plus 3 is equal to 0 has roots alpha, beta, gamma. The value of alpha plus beta plus gamma is which one of these? So we know from roots of equations, this whole cubic equations topic, right? Cubic functions and equations, that all this comes down to is one formula. Because we know that alpha plus beta plus gamma is minus b on A. Okay? So we can gather A and B. From this, we know that A is 5 and B is minus 2. Don't forget the minus. B is minus 2. We plug it into this formula. We have minus 2 over 5. Minus and a minus makes a positive. So we get positive 2 over 5. And that is how easy that was. So, in case you forgot the rest, we know that the sum is minus b on A. The sum of the pairwise products of the roots is c on A. And the products of the roots is minus d on A. Memorize those and you all will eat. Just like we just ate. Eat. You get? Yo, honestly, that's so cringy to me. But I just had to do it. Question 9. When tx cubed plus t squared x squared plus t cubed x plus t to the power 4 is divided by x minus t, the remainder is what? We know that because the remainder, well, first of all, the remainder theorem, which all of you are familiar with because we definitely did this before, even if it was before CAPE, we definitely did this. we know by the remainder theorem, for a polynomial f of x, the remainder when divided by x minus a is f of a, right? So we have the polynomial and we are dividing by x minus t. So we know by the remainder theorem, the remainder is f of t. Okay, so when we substitute x is equal to t and we simplify, all we have to do, so we know this is t to the power 4 plus t to the power 4 plus t to the power 4. So we have what? 1, 2, 3, 4. 4 t to the power 4, y'all. So we add all of them and then we get 4 t to the power 4. Is that an option? Yes, it is. Yes, it is. 4 t to the power 4. So again, recap, the remainder theorem. This is all you need to remember. That for a polynomial f of x, the remainder when divided by x minus a, so in this case, x minus t is just going to be f of t. So we substituted t into that polynomial. So we did that, substituted it, and we got 4t to the power 4, and it happens to be one of the answers. Is it correct? Yes, it is. Yes, it is. It is correct. Let's move on to question 10. Question 10 states, given that f of x is equal to 3 to the power of x, then f inverse of x is equal to which one of these options? So this is all about the inverse of an exponential function. We know that the inverse of f of x is equal to a to the power of x is equal to log base a of x, okay? And we also know that we have 3 or 4 steps to follow, simple steps, to be able to find the inverse of any function. So the first thing that we would do is to let y be equal to 3 of x. Then we take logs of both sides. When we do that, we're going to solve for x. So we have log y is equal to log 3 to the power of x. We're going to bring that x to the front using one of our laws of logs, which I told you all to go over. Solve for x, we get x is equal to log y over log 3. When we switch y and x, we get the inverse, which is log x over log 3. So in general, these are the steps to find the inverse of a function. So we know by that method that log x over log 3 is the inverse of 3 to the power of x. Question 11 asks us which of the following of the 4 graphs represent the function 3 over x, but the modulus of 3 over x. Okay, so that's what these 2 lines mean, the modulus. So the modulus means everything becomes positive. So if I were to send you through the modulus on a bad day, you would just become positive, and that's just how it works. Okay, it's a mathematical law, so you have to follow it. So the modulus function makes everything positive. We know that. That means that the mod of f of x reflects all negative values, this is in a graph, of f of x above the x-axis. So let's look at b, for example. If this was supposed to, like, let's just say this is a function, and it went through the modulus function, we would reflect this negative part over the x-axis, so it would look like this. Well, way better than that. This is an asymptote, right? So not supposed to touch. So it will look something like that, okay? In fact, just an example, this is what it would look like, okay? So let's go through the options. All right, so we are given y is equal to the mod of 3 over x. We first need to understand the graph of 3 over x. We know that the function f of x equal to a over x, where a is a constant, is a hyperbola. All right, so it has 2 branches, one in the first quadrant, so the first quadrant, and the third quadrant, right? So one is in the positive and one is in the negative, right? So this is just a over x by itself. So what would happen if you put a over x into the modulus? You put it through that transition. This would turn into the second quadrant, which is positive. This is positive, right? So it would be reflected over the x-axis and it would turn positive into the second quadrant. So keep that in mind. So again, it has 2 branches, the first quadrant and the third quadrant. So this is positive and this is negative. All right, so there's a quick sketch. So we can see that y is equal to 3 over x is actually just b, right? We could actually cancel this out because this technically just looks like a straight line. Probably y is equal to lambda x, where this could be any kind of constant. This is potentially x squared, okay? So what we have to do now is apply the modulus, where we reflect this above the, well, over the x-axis, and then we get something like this. So then we know that the answer is going to look like this. So the graph is going to look like this. This is a sketch of y is equal to the modulus of 3 over x. So again, the positive side, the first quadrant remains unchanged. So if I put you through the modulus and you're having a good day and you're positive, nothing will happen to you. You will remain unchanged. But if you were negative in the third quadrant, I will send you to the second quadrant where you will be positive. Okay? So our answer becomes A, where this is positive and positive. So two symmetric hyperbolic arms above the x-axis. This is eliminated because there are negative values in the first and third quadrants. We went over that. This is a parabola-like curve, so it's likely x squared. And this is most likely just some straight line, so any constant, okay? That's how we do number 11. Okay, so I want you all to rewind a little bit. Back to question 8 when we eat. So if you're still hungry, we're going to eat some more. So question 12 states that the sum of the squares of the roots of the equation 4x cubed plus 3x squared minus 2x plus 1 is equal to 0 is which one of these? So what we have to do is memorize this specific formula. And we already know parts of this formula because I know that you all memorized the formula for the sum of the roots and the sum of the pairwise products of the roots. Because I know you all know that this is minus b on a and this is c on a. Okay? So alpha squared plus beta squared plus gamma squared is just the sum of the roots squared minus 2 multiplied by the sum of the pairwise products of the roots. So when we figure out what b, a, and c are, we could simply substitute this in the equation, right? So let's do that quickly. We see that from the polynomial, a is 4, b is 3, c is minus 2, never forget the sign in front, and d is 1. Okay? When we let the roots be alpha, beta, and gamma, we know that the sum is equal to minus b on a, so minus 3 over 4, remember from the polynomial. Then the sum of the pairwise products is c on a, so minus a half. We substitute that, put it in your calculator, and then simplify to get 25 over 16, which is an answer. So I hope you all are full now. Let's do question 13, which says if f of x is equal to ln 1 minus 3x, then what is the inverse of f of x? Okay, so this is again the inverse of a function. We've already covered one of these questions before. Recall that ln a equals to b can be converted into the exponential form. So a is equal to e to the power of b. So we are given f of x is equal to ln 1 minus 3x, right? So let's begin that. First step, let y equal to f of x. So y is equal to ln 1 minus 3x. When we switch x and y and we convert to the exponential form, all we have to do here is solve for y, right? So again, we convert to the exponential form given, where is my pen? So we given this here, this is how you convert, this is the relationship between them. We get e to the x is equal to 1 minus 3y. Then all we have to do is solve for y, and this is our inverse. So we get 3y is equal to 1 minus e to the power of x, and of course, we bring the 3 down. We get the inverse to be 1 minus e to the power of x all over 3. So that is how we do number 13. Question 14 says, which of the following intervals is in the domain of f of x is equal to square root of x plus 2 all over x squared minus 9? Then we are given 3 interval options, and then for the answers, we are given a combination of these interval options. All right, so this is all about domain restrictions. We are going to define and establish a domain. The first thing that we will do is notice that this is a fraction, right? So this is divided by something. This is something over something. And we know that, first of all, if this becomes 0, this whole thing is undefined. And we also notice that there is a square root in here. So that means that if we have any negative numbers whatsoever, this is also just undefined. So that is quick thinking, right? Let's look at the numerator first. When we see that there's a square root in the numerator, we know that x must be greater than or equal to 0. So that is the first restriction that we can create, okay? We know that, yes, so x is greater than or equal to 0. That is the first restriction. Then when we look at the denominator, it cannot be 0, all right? So we let x squared minus 9 not equal to 0. We know that x cannot be plus or minus 3, okay? So with these in mind, let's define the domain. The domain of f of x is greater than or equal to 0, and x cannot be equal to 3. So here's how we write it in symbol form, using our square brackets and our rounded brackets. We have from 0 to 3, including 0, but excluding 3. The difference here is when there's a square bracket, it means you include this particular number. But if it is rounded, you exclude that number. So from 0 to 3, including 0, but excluding 3, union. From 3, you're not including 3, right? Because of this bracket, this particular rounded bracket. So from 3 to infinity, but excluding 3. All right, so again, review of what the different brackets mean. Now we're going to look through the different intervals and see which one fits our domain. So it could be more than one as well, because we were given several options, right? So let's see. Starting from number 1. X is between minus 3 and 3, but is also equal to 3. This immediately is invalid because it has x is equal to 3. And that would cause division by 0, and that whole thing is just undefined. So that is wrong, eliminated. Number 2, x is between 0 and 3. So this whole thing here works. It is valid because all values satisfy x is greater than or equal to 0, and it does not include 3, okay? Very simple requirements we have, for them to be included, okay? So x is greater than minus 2 and x is less than 3. This is invalid because it includes negative x values here, where the square root will be undefined in the numerator. All right, so we are left with one option only, that is number 2, and that in fact is an option B. So that is how we solve question 40. Question 15 is for those of y'all that don't have a fancy calculator. We're going to go through this because the majority of y'all could just plug this into your calculator and be able to tell which one to 4 decimal places is. Okay, so solution for those of us that are not as fortunate. We need to find log base 2 of 17. Okay, we are going to use the change of base formula to put the base 2 into base 10 because that's what our basic calculators could manage. At the end of the day, you still have to use a calculator for this, but if your calculator cannot take bases other than 10, you have to use the change of base formula and then plug it in using base 10. Okay, so change of base formula is used when converting between different bases. So here you can see log base a of x, we are converting from this base a to base b. So we have log base b of x over log base b a. And this is how you convert it, right? So in this case, our new base is 10 and our old base is 2. We put our old base here. So it'll be log base 10, 17 over log base 10 of 2. And then when we plug it into the calculator, we get this, right? The question specifically asks for 4 decimal places, although this is quite blurry. Put on your glasses. I don't know why it does that, but it says 4 decimal places. So we have 1, 2, 3, 4. This number is greater than 5. So this becomes 5. So when we round to 4 decimal places, we have 4.0875, and that is the answer. Question 16 may seem intimidating to a lot of people because it has a lot of cussing and sinning, right? But for those of you all that are familiar with the new line of clothing from Trigonometric Identities, that line of clothing, and the trigonometric functions and stuff like that, you would be quick to notice that this is just one of these in disguise. And it is about knowing that particular line of clothing or that particular identity that they're trying to, become. So they use to become something that you would quickly be able to identify which one is cos 60 minus cos 45. So I know you all already know this, but in particular, we are using the cosine difference identity because they wanted to stop cussing and start sinning more, right? So immediately, we know that cos 60 minus cos 45, where A is 60 and B is 45, was plugged into this new formula to create this new identity using this identity. They simply simplified A plus B. So 60 plus 45 and 60 minus 45 divided by 2, plugged into this whole formula and became this whole new person, right? So again, look over this, but mostly memorize this if you want to stop cussing and start sinning more. Stuck for last. Basically, all you need to do is memorize the identities, okay? So again, these are just fun ways for you all to be able to learn these things and remember. But again, learn the identity. So I have a trig video up. I definitely recommend you all go back and just, even if you don't want to watch the video, I have a section where I literally screenshot all of the things that you need to learn. So all the formulas, just pause, write all of those down, memorize it, because it makes things like these extremely easy. Okay, so question 16, D is the answer. Is it really a CXC paper if there isn't a slight anomaly? Well, this is it. So question 17 poses a slight potential error. I actually don't know if it's an error or if I am just having some issues being able to solve it, which is always okay too, and that's fine. You don't have to be perfect. So if you all do know, please do let me know what the solution to this is, because my approach to it was just using the difference of squares and then using identities to be able to solve it. I did that several times. So that was attempt 1, and then as you could see here, I just kept getting 1 plus cos 2a, which isn't an option, and I don't think I could have just crossed out the 4 and put a 2. So left with a problem. And then on attempt number 786, I just decided to substitute a value and see which option matched. Then, after substituting the angles, the only option that matched was a
I found it all on my own. It's little and broken, but still good. Yeah, still good.
Vectors is a huge topic in Module 2, and we learn quite a bit about it, and this question is going to test our knowledge just perfectly. So question 18 states, given that A is equal to I minus J, and b is equal to minus I plus 2j plus 3k, and OP is equal to a plus 2b, and OQ is equal to 2a minus b, then what is the dot product of OP and OQ? Okay, so we are looking at the dot product of 3D vectors. So the scalar or the dot product of a and b is given as such, where a dot b is equal to a times b plus a times b plus a times b. All right, so it is a times b plus a2 times b2 plus a3 times b3. Okay, so that is how we do the dot product of two 3D vectors. So let's start with what we are given. We are given this piece of information here. We're given A, B, OP, and OQ. Okay. However, for OP and OQ, we only know how they are related to A and B. Okay. So we want to find OP dot OQ. So the first thing that we're going to do is express A and B in component form, right? So when we do that, we are able to calculate OP. Okay, we know that OP is equal to A plus 2B. So by using simple rules, we know that, well, first we could start with this side. This would be equal to, this side only would be equal to minus 2, 4, 6. Okay, so this is the component form of what this is equivalent to. Then when we add this one, so when we add A to it, we get 1, so minus 1, sorry, 3, and 6. Okay, so 0 plus 6 is 6. Then we go on, so forth, and so on, and so forth. Calculate OQ, which is 2a minus b. Same thing we do in, so this would be 2 minus 2, 0, minus, so 2 minus minus 1 is 3, minus 2 is minus 4, and 0 minus 3 is minus 3. So that would be OQ. So now that we have OP and OQ, we are now able to find the dot product, okay? Which we know to be this formula here, all right? So the scalar, the dot product of OP and OQ is given as such. All we do is we multiply, so it'll be minus 1 multiplied by 3 plus 3 multiplied by minus 4 plus 6 multiplied by minus 3. When we simplify all of that, we get minus 33, and that is our answer. Question 19 states, given that f theta is equal to cos theta plus 3 sine theta, r is greater than 0, and theta is between 0 and pi over 2, f of theta can be expressed as which one of these? So this is under our topic, trigonometric functions of the form a cos theta plus b sine theta is equal to c. And we have two very special formulas that we know to be able to find r and tan alpha, because we know that a cos theta plus b sine theta can be put in the form r cos theta minus alpha. Okay, so there are other variations that we can do for this as well. So I highly recommend you go look at that video if you have the time to. So just a quick review. We are given f theta, so that's cos theta plus 3 sine theta. We know the restriction. We need to express it in this form, r cos theta minus alpha. So we have to identify a and b using this, okay? So from theta is f theta is equal to cos theta plus 3 sine theta, we know that it's in the form a cos theta plus b sine theta, where a would be 1 and b would be 3, okay? So we're going to use the values of a and b to be able to find r. R is equal to the square root of a squared plus b squared. So in our case, 1 squared plus 3 squared, which would be 10. So the square root of 10. And we need to find alpha, where tan alpha is equal to b over a. So we have 3 over 1. So alpha would be equal to arctan 3. Therefore, our final answer would be this. All we have to do is match this now to an option. Right? We get the square root of 10 cos theta minus arc tan 3. Okay, so it was that simple as just being able to recognize the form and manipulate it. So we are going to be able to put it into r cos theta minus alpha and find the value of r and alpha to be able to solve that question. Question 20 states that a curve C is given by the parametric equations x and y, where x is equal to 3t plus 2 and y is equal to t squared plus t minus 6. The Cartesian equation of C is one of these options, and we need to figure out which one. So, ideally, by the end of this, we eliminate the entire parameter t, and we are going to do that using the following method, okay? So we want to eliminate t entirely. So you can see for the Cartesian equation, there's no t. All right, we only have x and y. So the first thing that we're going to do is put t in terms of x. And the reason for this is so we can substitute that into the equation for y, right? So when we solve for t in terms of x, we're going to get t is equal to x minus 2 over 3. When we substitute t into the equation for y, we are going to get y is equal to, and then we substitute here and here. So x minus 2 over 3 squared plus x minus 2 over 3 minus 6. We're going to simplify it, okay? So as you can see, we have already eliminated t entirely, which was our goal in the first place. All we need to do now is simplify it, and that would be our answer. So after we simplify it, we're trying to remove the denominator, so we multiply by 9. And then we get 9y is equal to x squared minus x minus 56, and that would be our derived Cartesian equation, and it happens to be option A. So that is the answer for question 20. Question 21. The set of values of k for which the straight line y is equal to kx minus 4 intersects the curve with the equation y is equal to x squared minus 2x at two distinct points is which of the following? So we're given two things, a straight line and a curve, okay? We want to find two distinct points, and at this point you should know that we have to use the discriminant b squared minus 4ac, okay? So we are given a straight line and the curve. These are the equations for both. We need to find the set of values of k for which the straight line intersects the curve. The first thing that we do is set them equal to each other. All right? So we're going to set them equal to each other. We have kx minus 4 is equal to x squared minus 2x. So when we bring all the terms to one side, we can see that this is a quadratic in x. So we're going to use the discriminant b squared minus 4ac, and it must be positive, right, for two distinct real solutions. So the discriminant d is equal to b squared minus 4ac is greater than 0 because positive. So we have a is 1. So yes, a is 1, b is minus k plus 2, and c is 4. We're going to substitute it to find that it is k plus 2 squared minus 16. We need to set that greater than 0 to find positive. Then we have an inequality. So what we're going to do is take the square roots of both sides. So that's going to use the absolute value. Then we remove the absolute value by splitting into two inequalities. So we'll have k plus 2 is greater than 4, or k plus 2 is less than minus 4. So we're going to subtract 2 from both sides. So we'll have k is greater than 2, or k is less than minus 6, and that gives us our answer here. So again, all we do in there is setting them equal to each other using the discriminant b squared minus 4ac, setting that greater than 0, because positive, then we are going to solve the inequality, and we get our answer. Okay, so in this case, it is C. Question 22. So question 22 states that the curves y squared is equal to x plus 7 and xy is equal to 6 intersect at 3 points. The y coordinates of these points are which of the following? Okay, so we are looking at points of intersection of curves, and we know to solve that, we need to solve equations simultaneously. That means we label curve 1 and curve 2. So we have curve 1 and curve 2. We are going to substitute 2 into 1 to get y squared is equal to 6 over y plus 7. All right. So you see that we derived x from 2 here. So y is equal to 6. That means x is equal to 6 over y. We're going to substitute x into equation 1. So we'll have y squared is equal to 6 over y plus 7, which is what we have here. What we're doing here is trying to simplify it, okay? So we are multiplying both sides by y to get y cubed is equal to 6 plus 7y. When we bring all terms to one side, we notice that we get a cubic. All right, the cubic equation. We are going to try the rational root theorem to solve the cubic. So that means testing out different factors, right? So we're going to try y is equal to minus 1 first. So if we substitute that into the equation and get 0, we know that it is a root. So we're trying to solve to figure out what the roots are, okay? So because we do get 0 from after substituting minus 1 into the cubic, we know that y is equal to minus 1, or minus 1 is a root, okay? So now we can do polynomial division or factor out to get the quadratic. So you can see here that because we know that minus 1 is a root, we could put y plus 1 and then we could factor it out. So we know that y squared minus y minus 6 multiplied by y plus 1 is equal to this. And all we have to do now to find the other two roots is what we always do. So luckily for us, this was super simple. Remember that all we have to do here to solve this quadratic, this quadratic, is split up these. So split up this into 2. So minus 3 multiplied by 2 has to be equal to minus 6. And of course, minus 3 plus 2 is equal to minus 1. So minus y. So that works. We are able to get y minus 3 and y plus 2. Therefore, minus 2 and 3 are also roots alongside minus 1 himself, which is where we came from. So we have to thank him. So we know that the roots are minus 1, minus 2, and 3, which is option A. Question 23. The circle with center 0, 0. So let's write this out. So 0, 0 has a radius. Yes, all circles have a radius. 6 units. And the equation of the line, that's a tangent to the circle. So we have a tangent at the point minus 5, 4. And we want to find the equation of this tangent. Perfect. Okay. So a circle with center 0, 0 has a radius of 6 units. The equation of the line that's a tangent to the circle at minus 5, 4 is one of these. And you need to figure out which one. So the first thing I want you all to do is draw out a little sketch. Okay, that's always going to help. So we can see that this is the sketch here. We are given the center of the circle and the point of tangency, which is minus 5, 4. The first thing that we're going to do is find the gradient of the radius. Okay, so this is the center, right, to the point here. Okay, we're going to be able to do that using both of these points. So we know that the gradient is y2 minus y1 over x2 minus x1. So we have minus 4 over 5. The tangent is perpendicular to the normal, okay? So in this case, this is the normal. So the gradient of the tangent is the negative reciprocal of the gradient of the normal. So that means that it's the negative reciprocal of minus 4 over 5. So the negative reciprocal of 4 over 5, as we know, when we negate it, we get positive, and then it would be 5 over 4 when we reciprocate, okay? So now we use the point slope form of a line, which is very, very useful. So we use this when we have the gradient and a point on the line. So we have the gradient, which is 5 over 4, and we have a point, which is minus 5, 4, okay? We're going to substitute those values into the point slope form of a line, substitute the values. So we have y minus 4 is equal to 5 over 4, x minus minus 5, it becomes a positive. When we multiply throughout by 4, we end up getting 4y is equal to 5x plus 41. Then we put it into the recognizable form, So we look at the options. We notice that we want 5x first. So we're able to put it into the form and recognize that the answer is D. 24. The curve whose Cartesian equation is given by x minus 3 all squared over 16 plus y plus 4 all squared over 9 is equal to 1 may be represented by the parametric equations. Which of these? So the first thing that we notice is that this is actually the standard form of an ellipse. Okay, so we're looking at parametric and Cartesian equations of an ellipse. So we are given the equation of the ellipse. We notice that it is basically looking just like the standard form. So a squared is equal to 16, so therefore a is equal to 4. B squared is equal to 9, therefore b is equal to 3. Okay? The first thing that we are going to do, besides identify the fact that it is an ellipse, we are going to identify the key features. So the first thing is the center. It is given by HK. So we can see here that it is 3 minus 4. Beware of the signs. Okay. We have the major axis. And since 16 is greater than 9, we have the major axis to be 4. Okay. So this is the square root of 16, 4. The minor axis would be 3. And then the orientation would be horizontal major axis, okay? And this is because a squared is equal to b squared, and a squared is under the x term. So now we have the general parametric equations. The standard parametric form of an ellipse is x is equal to h plus a cos t, and y is equal to k plus b sine t, okay? So when we plug in the values, the general parametric equation for an ellipse centered at hk are, and then we are going to basically plug in the values into these, or it could be these, and we check which ones match the options. The reason we can switch sine and cosine is because t is a general angle. So we are basically substituting it into all of these and checking which options match whatever is in the answer. So in this case, these options match option C. So therefore, the answer for 24 is C. Question 25 states that a circle is defined as x plus 2 all squared plus y squared is equal to 4. It asks for the gradient of the normal to the circle at 0, 0. So we have a point and we have the equation, okay? So this circle, the equation is this and the point is 0, 0. The first thing that we do using the equation is identify that the center is minus 2, 0 and the radius here is 2, okay? So that's the first thing we know. Then find the gradient of the normal. M, it means gradient, remember that. So m radius is going to be the normal, right? So the radius connects the center, minus 2, 0, to the point 0, 0. So we have these 2 points. So we have y2 minus y1 over x2 minus x1 to get 0 over 2, which will just be equal to 0. Now we determine the gradient of the normal. Since we have the gradient of the radius, we know that the gradient of the normal would just be the same. So the normal to the circle at any point is the same as the gradient of the radius at that point. Therefore, the gradient of the normal is equal to 0. And therefore, the answer is 0. And it was that simple. Question 26. The general solution of cos 2 theta is equal to cos pi over 3 is theta is equal to which of the following? So we are looking at the general solution of trigonometric equations. So we need to recall firstly that the general solution for cosine equations cos A is equal to cos B is A is equal to 2n pi plus or minus B. Okay? So we are given cos 2 theta is equal to cos pi over 3. Okay, so we're given this. The general solution we know. So we have A is equal to 2 theta and B is equal to pi over 3. So we know that 2 pi is equal to 2n pi plus or minus pi over 3. Okay, so we're going to solve for theta now. We're going to get, all we have to do now is just divide, of course, there and there. And we're going to get theta is equal to n pi plus or minus pi over 6. And we can match that with A. Question 27 is about circles again. Surprise, surprise. So they really enjoyed having a lot of coordinate geometry and stuff. So a circle has center, -1, -1. The equation of the tangent to the circle at the point 0, -3 on the circle is which of these? So this is all about deriving equations of tangents and normals to a circle. So we need to understand the geometry of a circle for this. We are given the center of a circle. Well, that's not the center. Okay, the circle gone. Circle, center, -1, -1. And then we're given the point of tangency to be 0, -3. Okay, the first thing that we're going to do is find the gradient of the radius, so this line. Okay, so we're going to get -2 over 1 when we plug it into y2 minus y1 over x2 minus x1. We're going to get -2. Then we're going to find the gradient of the tangent, knowing that the relationship between the gradient of the tangent and the gradient of the radius is the gradient of the tangent is equal to -1 over the gradient of the radius. So we know the gradient of the radius. We can now derive the gradient of the tangent to be -1 over -2, which ultimately is just a half. We're going to use the point-slope form of a line, which is always fun. We have a point and the slope or the gradient, same thing. We're going to substitute it into this form, simplify it to get y is equal to a half x minus 3. If that is an option, then we choose it, and it happens to be D. Question 28 states that, given that the magnitude or the length of OP is equal to 24 units, what is OP equal to? So we are going to reverse engineer this whole thing and just substitute the options. So we're going to, by process of elimination, find the answer. So we are going to substitute all the options into the vector magnitude formula, which we know to be the square root of x squared plus y squared plus z squared. And if we get 24, it is correct. If we don't, it is incorrect. And therefore, we eliminate the option. So let's begin with A. We have x is 6, y is -6, and z is -3. We plug it into the formula, simplify to get 9. It is incorrect. Eliminate A entirely. B, you can see here the green tick, which means that when we substituted these values into the formula, we got 24. I did not do C and D. However, if you do C and D and get 24, I owe you 1 Colombian peso. Okay? So let's hope that they didn't make an error and B is the answer. Coming in again with vectors in 29, the vector A is given as 5A plus 12J. A unit vector parallel to A is which of these? So, finding a unit vector. So always remember, a unit vector in the direction of a vector A, any vector, AA in this case, is equal to the vector over the magnitude of the vector. All right? So we already have the vector itself. All we need to do now is find the magnitude of A, okay? We know the formula already, so we have to square it, add them, and then take the square root. We get 13. So we divide the vector by its magnitude, and it was as simple as that. We put it into the recognizable form that they use here, and in this case, the answer is B, 1 over 13, 5I plus 12J. Question 30 asks us to obtain the minimum value of the function 8 sine theta minus 5 cos theta. So the question could either ask us to obtain the maximum or the minimum value. And in this case, it is the minimum. Keep that in mind. So obtaining the maximum or minimum values of the function of the form a cos theta plus b sine theta is what we're going to learn how to do now. So as you may be familiar with, we actually are familiar with because we did this question earlier I'm not sure which number, but we did it earlier. We can express a sine theta plus b cos theta in the form r sine theta plus or minus alpha. Okay? You also know that r is equal to the square root of a squared plus b squared. What you may not know, and which I hope you do know, is the maximum of r sine theta plus or minus alpha is equal to positive r. So positive r. However, if you wanted the minimum value, which is actually what we're looking for right now, we would want to know that it is negative r. Okay? So all we have to do right now, what we actually have to do is just find r. Okay? And not only r, we need to find minus r because we want the minimum value. However, if they ask for maximum, we would keep it positive. All right? So we are given this function. So we know that it is of this form, so we can find a and b. This is important because we needed to find r. We put it into the formula and we get r to be equal to the square root of 89. But don't just stop there, because if you chose that, it would be wrong, because this is the maximum. What they are asking for is the minimum. So the minimum would be minus square root of 89. Again, the minimum is minus r. So that is how you do question 30. Question 31 brings us into some module 3 content, because as you can see here, we have some differentiation involved. So we are given y is equal to 3x plus 1 over 2x plus 1, and they want us to find dy dx. So this is quite simple because all we have to do is use the quotient rule, which states that dy dx is equal to v du dx minus u dv dx all over v squared. And yes, you have to memorize that if you haven't already. So this is of the form y is equal to u over v, as we have in the question, u over v. So we are going to let u equal to the numerator and v is equal to the denominator, and let's start differentiating. We know that du dx would simply be 3. This is gone, and of course we remove the x. Same goes here, dv dx would just be 2. Now that we have all these values, u, v, du, and dx, all we need to do, all that's left to do, is plug it into the quotient rule. If successfully done so, and all your working is correct, make sure that you focus on the signs, always the signs. Be very careful. The final answer should be 1 over 2x plus 1 squared. Okay? So that gives us b. Question 32 is also differentiation. However, it involves trigonometric functions and the chain rule. So if y is equal to tan 5x, then dy dx is what? So we know that the chain rule is dy dx is equal to dy du multiplied by du dx. And this is because we could just cross off the du's, right? So it's equal to the same thing. We know that y is equal to tan 5x. That's what we were given. So we're going to let u equal to 5x, and therefore y would be equal to tan u because we made u equal to 5x. We're going to differentiate both of these. Okay, so we get du dx to be 5, and we know that the derivative of tan is equal to sec squared x. So tan x is sec squared x, right? So dy du would be sec squared u. Therefore, dy dx would just be equal to dy du multiplied by du dx. So 5 multiplied by sec squared u. Therefore, 5 multiplied by sec squared 5x, and that is our answer, which also happens to correspond to b. And on to our third question on differentiation in this paper. Question 33 gives us y equal to 4x cubed minus 3 sine 6x. Then d squared y over dx squared is what? So d squared y over dx squared is simply differentiating twice. Okay, so you differentiate once. So if you get x, let's just say, and you differentiate again, that is what it is, right? So you're simply differentiating twice. Okay, so let's do dy dx first. We differentiate that, we get 12x squared minus 18 cos 6x. Now to get d squared y dx squared, all we do is differentiate this. So it is actually that simple. I know the way it looks seems a little daunting, but it's really that simple. So the final answer we would get, or what we should get, is 24x plus 108 sine 6x. So as long as you know the rules of differentiation, these will be super easy for you. So this is D. Question 34 is all about limits. So a dial on a plane preparing for landing registers the number 200 plus 5 sine h over h, where h is the height above the ground. Just as the plane lands, the dial reads what number? Okay, keywords. As the plane lands, we know from this that h tends to 0. Okay, we also know from our special limit law, one of them, that the limit of sine h over h as h tends to 0 is 1. So what we know is our function. We know that as the plane lands, it means h tends to 0. And we know our limit law. So all that's left for us to do is put them all together. We would get 200, this is the formula, 200 plus 5 multiplied by 1, because this equals to 1. Add 200 plus 5, and that's the answer, 205. So 34 is B. Question 35. The displacement s meters of a marble moving along a board at time t minutes is given by s of t is equal to 40 cubed minus 30t squared plus 72t plus 7 for t is greater than or equal to 0. For what values of t is the displacement of the marble increasing? So what we are doing here is using first derivatives to determine whether a function is increasing or decreasing. So we're given the function s of t. What we are going to do is find the values of t such that the derivative is greater than 0. Why greater than 0? It is because we want to find where the displacement increases. So if we wanted to find where the displacement decreases, then we would use less than. Okay, so it would be negative. Now it is more than 0. Okay, so we find the derivative, which would be, of course, 12t squared minus 60t plus 72, and this is a constant, so that's gone. We set it to greater than 0. We simplify. Of course, we solve the inequality, and by this, we know that s prime t is greater than 0, where t is less than 2 or t is greater than 3. So all we did, again, find the derivative, set it to greater than 0, solve that inequality, and that is how you would solve this question, and the answer is D. Number 36 brings us back to limits. So it says the limit of sine 3x over 2x as x tends to 0 is which of these values? So we know that the standard limit law, the limit of sine x over x as x tends to 0 is 1. We've used it already. We are given this limit. So we want to be able to apply this limit law. Okay? So what we are going to do is multiply by 3 over 3. And we could do this because this is essentially equal to 1. 3 divided by 3 is 1. Right? So what we're going to do is put it into a form that we could recognize to be able to apply the limit law, the standard limit law that I just showed you. So we are multiplying it. Then what we are doing is switching the denominators. And I think if you look at it carefully, you can tell why we are switching the denominators. We are switching the denominators to be able to separate them, and one of them happens to be equal to 1, when you apply the standard limit law. And that means that the answer is 3 over 2 multiplied by 1, and that leaves us with 3 over 2 to be the answer. So the answer is C for question 36. 37. A curve C is given by the parametric equations x is equal to 4 sine theta and y is equal to 3 cos theta. The Cartesian equation of C is one of the following. This is actually quite random. I thought they would continue with some more Module 3 content, but this is interesting. So we are meant to basically eliminate the sine and cos, because look at the options, there's no sine and cos. How would we do that? We can combine them using an amazing identity we've all learned since we were 3 years old, because they couldn't stop engraving it into us. Sine squared theta plus cos squared theta is equal to, I know you know, 1, right? So we are given x is equal to 4 sine theta and y is equal to 3 cos theta. We are going to express sine theta and cos theta. So we're making them the subjects of the formula, because when we do that, we can substitute them into our Pythagorean identity. Sine squared theta plus cos squared theta is equal to 1. We find sine theta, we find cos theta, we plug them in. Okay, when we substitute them and we simplify, we are able to recognize the equation of an ellipse. But here, that doesn't even matter. All we want to do is eliminate those denominators. To do that, we find the lowest common denominator of 16 and 9. Hint, hint, if you just look at the options, I think you can know what it is. So it happens to be 144. So we multiply throughout by 144. Then we, of course, simplify this to get 9x squared plus 16y squared is equal to 144. And that is option C for 37. Question 38 is bringing us back on track with Module 3, because it is testing us on integrals or antiderivatives. So we are given dy dx, well, y prime is dy dx, is equal to cos x minus sine 2x. And they want us to find y. And the only way to do that is to integrate cos x minus sine 2x. So to do that, we are going to split up the terms and integrate both of them separately and then join them. So cos x dx, the integral of cos x dx is sine x plus c, and then of the form, to integrate the form sine ax dx is equal to minus 1 over a cos ax plus c. So c is just the constant of integration. In this case, we have a to be equal to 2, so it'll be minus 1 over 2 cos 2x plus c, and then we have the minus sign in front, so this all becomes positive. Then we add this up to get this combination, which is sine x plus a half cos 2x plus c, and it happens to be option B. Question 39 has to be one of the easiest questions in the entire paper, because all we need to know is one simple integral, and this is the integral of a to the power of x, where a is a constant. And we should all know that the integral is a to the power of x dx is equal to a to the power of x over ln a plus c. So they're asking us for the integral of 3 to the power of x. So we know that the integral of 3 to the power of x dx is equal to what? 3 to the power of x over ln 3 plus c. Okay, so use this formula, memorize that formula, and that would have taken probably 10 seconds to just recognize that that is what the answer is. So here the answer would be B. Question 40. For which of the following values of x is the function f of x, which is equal to 3 over x plus 5, x plus 3, discontinuous? So we're looking at points of discontinuity. And this is super simple, because all we have to do is set the denominator to 0 and solve for the values of x. And these would be the points of discontinuity. So let's look at that now. We are given the function. The function f of x will be discontinuous where the function is undefined, i.e. set to 0. Alright, so we set the denominator equal to 0 to find where the function is undefined. We solve for x, and the discontinuities of the function would be x is equal to 5 and minus 3. So our points of discontinuity are minus 5 and minus 3, which is option A. Question 41 asks us to integrate x multiplied by x squared plus 3 to the power of 4. Okay, so we're going to integrate using substitution. Okay, we will use the substitution method, and we will let u equal to what is inside. Okay, so the composite function, what is inside, we let u be equal to. All right, so we have to differentiate u, and we'd get du dx is equal to 2x. Of course, constant is gone. So we are going to make x dx the subject to the formula, and y to be able to write the integral in terms of u. All right, so x dx would be equal to du over 2. So all we did here was move the 2 over. Now we're going to rewrite the integral in terms of u. So we substitute u and x dx, all right, since we have the values of u and x dx, so we put it into the original integral. We get the integral of u to the power 4 multiplied by a half du. We simplify it by just pulling the half to the front. Okay, now we're going to integrate with respect to u. When we do that, we get u to the power of 5 over 10 plus c. Now we're going to substitute our value for u, or what we made u to be equal to in the beginning, back into the equation, and then we're going to get the final answer. So we have x squared plus 3 to the power of 5 all over 10 plus c. If we put it in a slightly different form, which is just bringing this out, we will get the final answer to be D. Question 42. If the rate of change of y with respect to x is 3x squared plus 4 over x cubed, then y is equal to what? So we are given dy dx. So the rate of change, that is the derivative dy dx. So what we are doing is we are finding the original function given the derivative using integration. So what we are going to do is integrate. Okay, so we're given dy dx, we're going to make it into a form so it is easier for us to integrate both the terms. So we'll start with 3x squared, we get x to the power of 3. We know, of course, our basic laws of integration. And then the same for 4x to the power of minus 3, we get minus 2 over x squared. When we combine both of these, we get our answer for the integral, and therefore we were able to find y, okay, which is C. Question 43. The portion of the curve y is equal to 2x between x is equal to a and x is equal to b is rotated 360 degrees or 2 pi radians about the x-axis. The volume V of the solid generated is best represented as which of the following? So what we are going to do is use definite integrals to find the volume of a solid revolution about the x-axis. So we know that y is equal to 2x. The interval is xa to xb, and it's a rotation about the x-axis. All right? So we are going to use the volume of revolution formula, which is V is equal to pi, the integral of y squared from a to b. All right? So since y is equal to 2x, all we're going to do is substitute it. Then we're going to simplify it, and there we go. So 2x all squared is equal to 4x squared. When we do that, we can move the 4 in front, put it into that form that they wanted it to be equal to D. All right, so it was easy. All we had to know was the volume of revolution formula. Question 44 asks us to differentiate a composite function using the chain rule. So if h of x is equal to x to the power of 4 plus 2 to the power of 3, then what is h prime x? So what is the differential? Let's start by letting u equal to what is inside the bracket. This makes our lives much easier, and then we apply the chain rule. Okay, so du dx is equal to 4x cubed, and then we of course differentiate h of x as well. So remember, when we let u equal to x to the power of 4 plus 2, which was what was in the bracket, h of x becomes u to the power of 3. We differentiate both of these separately. Okay, so we have du dx and dh of x over du. We have dh of x over du equal to 3u squared, and we multiply both of these using the chain rule to get the final differential. So when we do this, we substitute back u into this equation to get 12x cubed x to the power 4 plus 2 squared. And that is the final answer. C. And to end our wonderful and enlightening journey through this entire paper, let's end with question 45, which asks us to differentiate tan squared 3x. Okay, so what we are doing here is applying the chain rule to differentiate a composite trig function involving powers. So we are given y is equal to tan squared 3x. We're going to use the chain rule. Dy dx is equal to dy du multiplied by du di. I know you know it. Okay. So we're going to let u equal to tan 3x. If we let u equal to tan 3x and we know that y is equal to tan squared 3x, we now know that y is equal to u squared. We are going to differentiate both u and y separately. Du dx would be 3 sec squared 3x, so we know this, and dy du would be 2u. Okay, and when we substitute u back, we get 2 tan 3x. Now, to finalize all of it, bring it all together, and end it all, we are going to multiply it, because that is what the chain rule commands us to do. And when we do that, we end up with our final answer, 6 tan 3x sec squared 3x. And to end it all happily, question 45, the answer is A. Congratulations, you did it.